Welcome to our IT Department training session on understanding how an operating system works. An operating system is the backbone of any computing system, managing both hardware and software resources. Today, I will walk you through its key functions, types, components, and an important topic, concurrency and deadlock management. In this session, we will cover the fundamentals of an operating system, including its core functions, different types, and how it manages processes. Additionally, we will discuss concurrency and deadlock, which are crucial concepts in modern computing. So, what is an operating system? An operating system, or OS for short, is a software layer that sits between the user and the hardware. It provides a user-friendly interface while ensuring efficient system management. Without an operating system, a computer would be difficult to operate, requiring manual hardware control. Examples of operating systems include Microsoft Windows, Mac OS, Linux, Android, and iOS, each designed for different platforms and environments. The core function of an operating system. The operating system performs several critical tasks. Process management ensures applications run smoothly, allocating CPU time efficiently. Memory management keeps track of system memory and optimizes its usage. File system management File system management organizes files and directories, allowing for easy data access. And device management ensures proper communication between hardware components and peripherals like printers and external drives. These functions ensure a stable and responsive computing experience for the user. There are several types of operating systems, and they all serve different purposes. Let's start out with the single user operating system like Windows and Mac OS, which are designed for individual use, while multi-user, such as Linux, supports multiple users simultaneously. Real-time operating systems, short for RTOS, power mission-critical applications like medical devices and air traffic control. Nucleus RTOS is an example of a healthcare operating system used in the real world. Embedded operating systems are found in smart devices like TVs and iOS gadgets. And lastly, network operating systems, or NOS, such as Windows Server and Cisco, manage enterprise networks and centralized resources. The components and processes of an operating system. At its core, the operating system consists of several components. The most important is the kernel, as it directly interacts with hardware, managing CPU and memory resources. The UI, or user interface, can be a graphical user interface, which allows the user to interact with the operating system using visual elements. The command line interface, like Terminal Linux, allows the user to enter text into the operating system to communicate with the computer. Device drivers allow the operating system to communicate with hardware components, while background services and processes handle tasks such as security, networking, and application execution. There are several states of processes in an operating system. The new process is a process that is just being created and has not yet entered the ready queue. Ready is when a process is loaded into the memory and is ready to be executed by the CPU and is waiting in the ready queue. Running is when the process is currently being executed by the CPU and is using resources. Waiting or blocked, the process is paused. It's waiting for some event to occur, like an input or output operation to complete before it can continue its execution. Terminated occurs when the process has finished execution and is no longer active. And last, suspended. Suspended occurs when a process is temporarily removed from the RAM and moved to a secondary storage location, such as the hard disk, due to a lack of available resources. Important concepts to remember about the states of processes. A process can transition between any of these states depending on its current activity and resource needs. The operating system manages the process states by scheduling which process is currently running. You can find information about the process's current state in the process control block. Concurrency and deadlock. Concurrency is the act of multiple processes running simultaneously. Concurrency improves efficiency and performance, but it presents challenges, such as resource conflicts. To manage concurrency, synchronization techniques like mutexes and semaphores ensure that multiple processes do not interfere with one another. Concurrency can sometimes lead to deadlock, where two or more processes become stuck in an endless cycle, waiting for resources that are held by one another. This can cause a system freeze. Operating systems use deadlock prevention techniques such as resource ordering and preemptive resource allocation to avoid such issues and maintain system stability. To summarize, an operating system is essential software layer that manages hardware, resources, and user interactions. It ensures process, memory, file, and device management while supporting different types of computing needs. As we spoke about concurrency, it is crucial for multitasking and performance, but it must be carefully managed to prevent deadlocks. Understanding these concepts help IT professionals troubleshoot, optimize, and secure operating systems effectively.